single-phase semiconverter with highly inductive load. The load current is assumed continuous and ripple-free. When the supply is given to the transformer primary, it's going to induce the voltage in the secondary, that is Vs equals to Vm sine omega t. This is Vm sine omega t. In the positive half cycle, in this area, that is 0 to pi, thyristor T1's anode is having higher potential than the cathode, whereas T2 anode is having lower potential than the cathode. So we need to give a firing signal to the thyristor T1 in between 0 and pi. When it is pi to 2 pi, T2 anode potential is greater than the cathode potential and T1's anode potential is less than cathode potential. So during the next half cycle, T2 need to be turned on by giving a firing signal. So during the positive half cycle, that is omega t is in between 0 and pi, T1 is forward bias, so T1 is triggered at alpha. Then the current flows through, let this terminal be A and this terminal be B. So from A to T1, T1 to the load to D2, back to B. In this time, the input voltage is going to appear across the load. This is the output voltage. In negative half cycle, T2 is forward biased, and when it is triggered, the current flows through B to T2, T2 to load to D1, D1 to A. The input voltage is going to appear across the load. Even though this is negative voltage, this current flow direction is not going to change. It's going to flow from this point to this point. So the voltage appears in the positive half cycle only. It continues to be at 0 until the next time in positive half cycle. T1 is going to trigger at alpha. This is pi plus alpha and this is 2 pi plus alpha. So this is the output appears across the load. The remaining voltage is going to appear across T1 and the D2, 0 to alpha. And for this, pi to pi plus alpha. The current between IT1 and ID2, and this is the current IT2 and ID1. Whenever the thyristor T1 turns on, then the current appears with thyristors T1 and D1. This is also for T1 and D1. In negative half cycles between T2 and D1. When this T1 is turned off at pi due to the negative voltage and T2 is not turned on in between pi to pi plus alpha, the current is going to flow through the freewheeling diode to the load due to the inductor and E. That is going to appear in between DM, DM, freewheeling diode. Whenever these two thyristors are not turned on, the freewheeling diode is going to conduct the current run through the load. Then the I0, this is present, and this term here it is present, this is present. Then the total current will be continuous. So this is our assumption that the continuous output current ripple free. So this is our output current. In the positive half cycle, when the T1 is triggered at alpha, the input voltage is going to appear across the output. At the same time, current going to flow through the T1 and D2. When this thyristor is turned off, the current is going to discharge from the load to the freewheeling diode DM, and that gives a continuous current. In negative half cycle, when thyristor T2 is turned on, that is going to give the output voltage. At the same time, the current is going to flow through the T2 to the load. And when T2 is turned off, before the T1 turns on, the load current circulates through the freewheeling diode. Then the combining all the currents will get a continuous output like this. The average output voltage, that is VDC, is given by 1 by 2 pi integral alpha to pi 2 Vm, so sine omega t, d omega t. You solve this, then 2 by 2 pi Vm, the sine omega t integral is nothing but minus cos omega t between the limits alpha and pi. That will be Vm by pi of 1 plus cos alpha. This is our average output voltage. Average output voltage. Now, this will be maximum when the cos alpha is equals to 1. So VDC max is equals to Vm by pi cos alpha is to 1. 2 Vm by pi at cos alpha equals to 1. Alpha equals to 0 degrees. VDC is minimum 0 at cos alpha equals to minus 1 at alpha equals to 180 degrees. A normalized average output voltage Vn is given by VDC divided by VDC max equals to Vm by pi 1 plus cos alpha divided by 2 Vm by pi 0.5 1 plus cos alpha. Vn equals to 0.5 1 plus cos alpha. VRMS. RMS output voltage is equals to 2 by 2 pi integral alpha to pi Vm square sine square omega t d omega t whole to the power of 1 by 2 or under the square root equals to Vm by root 2 of 1 by pi minus alpha plus sine 2 alpha by 2 under the square root. This is an RMS output voltage and this is a normalized output voltage and this is average output voltage and this is the maximum average output voltage.